Now we're going to work with applied problems. You know them as word problems or story problems, but actually these are known as applied problems, and that's what we're going to be calling them from this time forward. So every time I talk about an applied problem, you guys should think word problems, okay? So when you're working with an applied problem, please you do not need to write out the whole thing like I have here. I wrote this out so you could see it. All you need to do is go from what I'm going to do from here past this. So when we do applied problems, the first thing you should always do is read through the whole problem without trying to do anything else. Then you should try and tell a 5-year-old what's going on in that problem without any math, okay? Just tell them the story of what's happening. If you can do that, you will be way better off, okay? The next thing we want to do after that is assign our variables and draw pictures. It's very, very important to assign your variables. If you don't assign variables, then you're going to have very, very much trouble. And assigning variables means writing let and then put a letter. So let x equal, let's say, and then you write a description of exactly what x is, not numbers, in words, okay? So we're going to be practicing that. The more specific you can be, the better off you'll be. Draw pictures, even if your picture is just one line, it can help. And then from there, go back and reread it and try and set up your equation. And once you have that, then everything else usually falls into place. Now listen carefully how your answer has to be. For every applied problem, your answer must be in a complete sentence. Okay, I'm going to say that one more time. For every applied problem that you have, your final answer must be done in a complete sentence. Okay, so let's get started. The surface of a rectangular bulletin board has an area of 300 inches squared. Find the dimensions if it is 5 inches longer than it is wide. So, what does dimensions mean? Well, dimensions means length and width. It's one word for those two things. So you can either talk about dimensions, which means you're meaning length and width, or you can talk about the length and width, which means dimensions. They're exactly the same thing, but don't ever use both of those terms. You don't use length and width and dimensions all in the same sentence, one or the other, okay? So we have this bulletin board and we want to know how long it is and how wide it is. There's my story to my 5-year-old, okay? So I am going to start by drawing a rectangular bulletin board, and I'm going to now assign my variables. I'm going to say let W equal the width, and then I'm going to say let L equal the length. Okay, now it says the surface of a rectangular bulletin board has an area of 300 inches. So this inside the whole thing is 300 inches. It says find the dimensions if it is 5 inches longer than it is wide. So length, 5 inches longer, the length equals, well, it's going to be 5 inches longer than the width. Okay, so width plus 5. That's what my length equals. Now, we need to know as well the formula for area of a rectangle. Well, the formula for area of a rectangle is length times width. Easy as that. So here I have an area, I have a length, and I have a width. So I've got everything I need. Just as a reminder, perimeter, which is going all the way around something, okay? The formula is 2 times the length plus 2 times the width, okay? That's just a reminder. We don't need that here, but I just wanted to remind you of that in case you run across it here. So let's do this. We know our area equals 300, and area is length times width. So my length times my width. Now I've got my equation and I'm ready to go. So 300 equals W times W is W squared, and W times 5 is 5W. Well, now this is a quadratic equation because I've got a squared term here. And my squared term, this is the only one in my equation, and this is an equation because it's got an equal sign. This is my only squared term, is positive, so I want to leave him here. So I am going to subtract the 300 from both sides and put him on the other side. Because I'm solving a quadratic equation, I need it in standard form, which is, there you go, ax squared plus bx plus c equals 0. So I've got 0 equals w squared plus 5 plus 5w minus 300. Because I subtracted 300 from this side, I have to subtract it over on this side as well. Okay, so now I'm going to ignore the 0 equals and just factor this. So rule number 1, any greatest common factors? Doesn't look like it. Rule number 2, let's see if it's a special factoring form. First question, is it a binomial? Well, it is not. So I know it's not a difference of squares. How about a perfect square trinomial? Is it a trinomial? Well, it is a trinomial, but this sign is not positive, so it's not a perfect square trinomial. So I just go on to rule 3, and this is 3a because this is a 1 coefficient. So the only time we do this, start with a double bubble, is right here. So I'm going to put a w in the front of each one. 1 times 300, so 1 times 300 equals 300, and let's find all our factors. Whoops. So 1 times 300, 2 times 150, 3 times 100, 4 doesn't go into it, 5 times 6 is 30, and then I just add the 0. Well, 6 times 5 is 30, and then I just add the 0. 7 doesn't go into it, 8 doesn't go into it, 9 doesn't go into it, 10 goes into it 30 times. Let's rewrite that. 30 times. 11 doesn't go into it, 12 does. 12 goes into 30 twice. That's 24, so that leaves me 6. So that's 60, and 12 goes into 65 times. 13 doesn't, 14 doesn't, 15 does. 15 goes into 30 twice, leaving just the 0. 16 doesn't, 17 doesn't, 18 doesn't, 19 doesn't, and 20. And I already wrote 20. So here's my pair, actually, that I need. Looks like it's going to have to be a negative 15, positive 20. Okay? When I add these two together, I get positive 5, and that's what I want. Last critical step, negative times a positive is a negative, and that's what I want here. And so I'm ready to go. I just take these and plunk them in, minus 15 and positive 20. Then I set each of these equal to 0. Whoops, equals 0, and w plus 20 equals 0. Let's solve these. I add 15 to both sides here, so I get w equals 15. And I subtract 20 from both sides here, so I get 20 equals W equals minus 20. Now, I am looking for measurements. So does that mean I can have a negative number? That's right. All measurements must always be positive. So I can't use this guy, okay? Negative 20 is not a measurement. So this is my answer. And W, oh look, W is my width. So now I know what my width is. That's one of my dimensions. So all I need to do now is find my length. And so length then equals width plus 5. And so my length equals 20. All right, so let's check this. Okay, so in order to check it, I need to put it back into my original equation, okay, which is actually this. Okay, so I've got 300 equals length, which is now 20, times width, which is 15, okay, 15. And so now we've got 300 equals, and 20 times 15, that's 0, 10, 0, 2. Add these up, 0, 0, 3. Okay, so 300 equals 300. So this is my width, and this is my length. And now I can write my answer, which is, can either be this, the dimensions, which again means both length and width. So the dimensions of the bulletin board are, because there's two dimensions, 20, and now I need to get my measurement, in this case it was inches, by, and when we say dimensions, we usually say by or put an X. So it could be written as 20 by 15 inches. Whoops, come back here. Inches. Okay, so by 15 inches. Okay, or I could write the bulletin board is 20 inches long and 15 inches wide. As long as whatever you write is a complete sentence. Sentences start with capitals, they end with periods, and they have to be complete. So there's the first. I'm going to do 3 more examples, so hopefully that will help you.